Thank you so much for watching another episode of the Weaviate Podcast. I'm super excited to welcome David Berenstein and Ben Burtenshaw from HuggingFace. David and Ben are pioneering such an exciting project, the synthetic data generator. They've done so much amazing work in the machine learning community. They work at Argilla. I've been following along for a while, and I'm just so excited to have this conversation. Guys, thank you both so much for joining the podcast.
Yeah, thanks for having us.
Yeah, thanks. Great to be here.
Awesome. So could we kick it off by just broadly explaining what is the synthetic data generator?
Yeah, maybe we can start off by explaining what is synthetic data in general. So in synthetic data in general is basically prompting an LLM in a smart way to create this synthetic data. It kind of mimics data augmentation in this kind of space. And the synthetic data generator is a UI that's built on top of the Distilabel, a library created for synthetic data generation that makes the process of creating synthetic data a lot more approachable to anyone out there.
Yeah, amazing. And so maybe if we could start with Distilabel then and come into how you built this app on top of it. So with Distilabel, I understand that you're generating synthetic data, but you also have this interface about giving feedback about the synthetic data. And so maybe if we could just dive further into Distilabel and like how the project was scoped and
Yeah, sure. Maybe I can take that one. Yeah, cool. So if you go all the way back, like Argilla started off as this human feedback tool. And so it was about people looking at data and building really high quality data sets. And then it got to a point with post-training techniques that a lot of people were using synthetic data and starting to use large language models and APIs to generate data and then reviewing that. So it made sense to have a library that did the other side of the coin, as it were, right? To generate the data that you would pair up with this human feedback UI and you would review the data and kind of iterate. And it was also a cycle that the team at the time was already doing to make these high quality data sets like ultra feedback and these data sets that were being used to train models at the time. So Distilabel really grew out of that process as like a implementation of algorithms from papers for data generation and integrations with API providers like OpenAI, but also models running locally.
Yeah, amazing. So maybe we can come back to the synthetic data generator on HuggingFace and kind of discussing more like the community and kind of the projects you're seeing. But maybe if for now we can just keep zooming into this synthetic data generation. What are the algorithms? Like I would imagine kind of maybe like my first intuition was, hey, let's sample a bunch of objects from the generative model and then maybe let's deduplicate it in some way. So what are these algorithms for generating synthetic objects?
Yeah, so I think there's a rough taxonomy that we can follow on a high level. I would say there's like data augmentation, where you go from like effective prompting for data labeling, data reformation, data rewriting, and then there's data synthesis, where you really distill data from a model, where you prompt a model to create completions, for example, where you do maybe specific domain distillation. And then when you talk about post-training data set, there's generally a differentiation between instructions, preferences, and critiques, where instructions are made up of prompt completions. Then you have a prompt completion, you generate another completion. And then based on the other completion, you might be able to score or evaluate both of these completions given the instruction, and actually end up with like this score for from which you can derive preferences or actually have some additional critique as to why a certain completion was scored higher than the other one.
Yeah, awesome. And so with synthesizing synthetic preference data, I guess maybe if we could even take a step back and talk about synthesizing data for like text classification compared to say like chat, and then maybe we could just start with that, like how you differ from synthesizing data from text classification versus chat. Sorry to say that twice.
Yeah, I think for the text classification, it's a thing that maybe arose a bit later, because at the beginning, when there was no data at all for fine-tuning large language models, people started generating a lot of these synthetic data sets with by effective prompting. One paper that was one of the earlier papers that actually was published, I think by the Stanford research team when actually creating Alpaca, was the self-instruct paper, where they prompted a model to take some context or take some initial instructions, and then based on those initial instructions or that initial context actually come up with alternative reformations of that same instruction. And that's one of these earlier ways to actually create synthetic prompts for models that they actually use to scale up initial seed prompts from 175 samples to a data set of more or less 50K samples, using those along with the ChatGPT version at the time to generate completions for that, and then eventually fine-tuned the model for completions. Similarly, I think what happened a bit later was the Ultra feedback paper, where there were a lot of these SFT data sets out there already. Used that data for prompts actually as a source data for generating completions with a lot of different models. So every prompt from the original source data was then prompted to any arbitrary model in a model pool, and those completions were then compared once again with ultra feedback based on these classical evaluation frameworks that we now actually know, all of us, like helpfulness, conciseness, effectiveness, and these kind of things, to actually come up with a score for each one of those completions. So those were the earlier approaches. And for text classification, it's not that different. But I think due to the lack of due to the fact that there's generally a bit more data for text classification, this actually came up a bit later in the research papers.
Yeah, awesome. So maybe if we could just zoom in on that first point of kind of paraphrasing instructions. I think this is such an interesting idea that you have some kind of eval set, and you could just kind of like paraphrase the inputs to get, maybe like a more holistic sense of performance, at least kind of like robustness is this other kind of like aspect of measuring AI models and how much their performance varies across, something like a paraphrase. So yeah, I guess I'm just curious, like when you're paraphrasing data to create more data, is there anything to be like, is that really high quality training data? What kind of insights are you gaining from, paraphrasing some originals? Let's call it set overall, like regardless of train test. Yeah.
So you focus there kind of specifically on paraphrasing, but I don't necessarily think it's limited to just that. If you look at the PersonaHub paper, which is an example of generating personas, like a description of a person to generate data from. So in that instance, they take a pool of data, say like articles from the web, and they generate a description of the type of persona that would write or read that article. So let's say it's a machine learning article, then the persona would be a machine learning engineer, and it would be a short description of that machine learning engineer. And then that persona can then be taken to generate instruction and response pairs that persona would use when they use an AI assistant or a chatbot, basically. So, you'd expect the machine learning engineer to say, how do I fix this CUDA bug? And then a response of a solution to that CUDA bug, for example. And from that, you can create a high variety data set by creating more personas and kind of fanning out. But at the beginning there, what you've created is this like dense representation of those documents in the form of a persona. But there are other formats for that.
Yeah, exactly. I think the paper tried to solve this approach where you either take seed data, which doesn't scale that well because it's always very specific and domain oriented, and also covering a specific topic already, or using these key driven prompt injections, so to say, where you, for example, want to start generating data according to different categories. Then you would initially generate a list of categories, and then upon prompting for generating synthetic data, you would continuously insert a random sample from the categories in your prompt to increase diversity. But by, for example, seeding, by generating these personas from the persona hub like a data set and using the, I think, red pajama data sets like red pajama v2. They actually had this very wide, broad source of seed data for generating these personas, eventually leading to way more diverse generation when ingesting those into the prompt.
Yeah.
And one thing
Sorry, Ben.
One thing I could add on there would be that around Distilabel and the synthetic data generator, we're constantly talking about post-training techniques. But many of these techniques have now more recently moved back into pre-training. So if you look at Llama 3's technical report and small LM2, you'll see that synthetic data goes all the way back to pre-training, as well as filtration and classification of those pre-training data sets to make sure that they are of the highest quality by filtering down and then synthesizing as well.
Yeah, also, so I think there are just so many exciting topics in this. Really, Persona Hub, I think is just one of these. It's one of the most interesting things I've seen. This data set of 1 billion personas, as you mentioned, from extracting who would read or write this particular text from this red pajama with one of these massive pre-training data sets. And if I can even just read to our audience quickly what these personas look like. One example is a software developer who is looking for a way to simplify the integration of gRPS technology data into their embedded system designs. And so there's 1 billion of these personas that read like this. And a bit of the experiments I've been doing are generating synthetic database schemas as we're trying to tune our query agent. And we're trying to get a data set that can help us test this. And you give it this persona and you say, generate a database that this person might want to use, like a schema that they might be interested in. And so I'd love to just open this box about persona-driven data generation. So if I'm training like a text classifier for email spam, do you think a persona could also be used in that? Do you think like this persona guided, is this the future of all synthetic? Like how big is this in terms of all the ways we're thinking about generating synthetic training sets?
So I guess one thing to add is the aspect of data that you can expect to get from a persona versus a document itself. And if you look at a document, for example, an unstructured pool of data, of information about a given problem, you can expect a language model to kind of synthesize that knowledge into a more relevant structure, like, for example, a schema. Whilst from the persona, you can't expect the language model to extract knowledge because the persona is such a dense representation of information, right? It might just be like 50 words explaining a role or a profession. But what we can expect a language model to get from persona is a variety. So we could give a language model this large unstructured document, like let's say the Weaviate documentation. And then you could take a persona of like a machine learning engineer, a software engineer, a front-end engineer, a database administrator, and generate instructions and responses or data schemas, as you say, from that same documentation from those 4 different personas. And what we would expect is 4 very different sets of instruction and responses based on those different personas. So I suppose that's for me, like the clearest way to understand what we can get from those two. Because I guess it's easy to compare back to not having personas, because without that, you would give this same large unstructured pool of documentation and say to the same language model, generate a set of instructions and responses. And typically it would just get stuck over the most represented part of that documentation and not look into those less represented but more relevant areas.
Yeah, and that's, I think, also a thing that we try to solve a bit with releasing this new version of the PersonaHub dataset that's actually been created by creating personas on the Fine Web pre-training dataset that HuggingFace released a while back. So this release is actually called Fine Personas, And then we actually reproduce this entire pipeline within Distilabel, codes publicly available on the HuggingFace Hub, personas completely publicly available on the HuggingFace Hub. And also we included vector search or cluster search, so to say, based on that, where you can, for example, as a company, you select a specific cluster. So let's say that you're interested in engineers, you would be able to search for the cluster of engineering personas, and then based on those personas, you would then be able to start generating this data. So this way it makes it also very more approachable to actually use these personas instead of the initial PersonaHub data set that was just a long list of like a long list of personas without having these specific clusters that you could use to focus on.
Yeah, well, I guess, yeah, one kind of detail about especially reproducing it, which is awesome because it's such a cool thing. I really want to dive into this, the deduplication with vector similarity. I know the Persona Hub paper says basically if it's cosine similarity of 0.9, that means, or higher, that means it's a duplicate, delete it. I'm just curious if there's any more nuance to it. You mentioned clusters, and so I have to think like there could be some exploration of synthetic data, like you cluster and maybe one cluster only has like 8 objects in it, whereas another has 500, or I don't know. I'm just thinking of this, but like it's like less explored. So maybe like let's go explore, let's go create more objects that might belong to that cluster. Or I'm just kind of curious what like the vector space of these generated objects, how that might be able to guide the generation process, as well as what you've learned from, I guess, a kind of deduplication with the 0.9 threshold kind of idea.
Yeah, I think a thing that they actually covered or used within the paper as well is this persona to personas prompt, where you have your initial persona that might be underrepresented within the data set, and then you would prompt an LLM to ask for similar personas that might interact with this specific persona. So let's say that you, for example, have a employee in a supermarket as a persona, and that you might also end up with a client for a supermarket, prompting the LLM for generating more personas. So that's a thing that we actually added within the pipeline, within the pipeline reproduction as well. And I think that can also help for like diversifying certain underrepresented regions within your data set, so to say. Yeah, and
Yeah,
I
yeah.
think. Yeah, and I think that's also one of the issues that you normally see when generating synthetic data. That's also a thing that Ben touched upon right before, is that whenever you start generating data, you actually set up a pipeline. You think you have a pipeline, you go through the entire pipeline from your basic prompt and you get some outputs, and then you start generating 10 samples, and that works fine. Then you start generating 100 samples, then you kind of hit a roadblock due to the fact that there's not enough diversity, maybe the quality isn't high enough, maybe you see some issues. Then you maybe improve your model, because larger model sizes tend to generate like better data, for example. And eventually you like iterate on the pipeline and iterate on the pipeline. But there's like some smart tips and tricks that you can use for that.
Yeah, I'm so excited to dive into the tips and tricks kind of and unpacking like the mechanism and the systems. I definitely could talk about Persona Hub for like an hour, but I don't want to make this whole podcast about that. But there's kind of one aspect to it that I think is so fascinating is I guess like with synthetic data generation, it's like we have like the seed set, and I think but it's kind of like with a persona you kind of have like a reference set. So it's like you're generating an object like per reference that you're passing in. I hope I'm like explaining how I'm seeing this properly, but like it's not just like generate in an open-ended way. It's like one per reference, and then now where I kind of struggle to generalize this is now you have this like crossover, right? Because you mentioned like with Persona Hub, you're I think they call it like the 6 degrees of separation, like how you have 6 hops, like how theoretically there are like at most 6 people between me and David and Ben if we're exploring like our social graph. And so you have this way of saying like we're gonna create these relationships between our objects. So it's like generate k objects, and then within the k you've just generated, now you have this like crossover step where it's like sample two and then form a relationship between them. Is that the right way of thinking about it? Yeah, sorry, I think I made that a bit like Like so we're there's some kind of like interaction between the objects that we've generated to create. So it's like, let's say David and Ben are two generated personas, and now I'm trying to come up with a relationship between you two to create another persona. Is that the right way?
You mean the persona to persona prompt that I was hinting at before?
Oh yeah,
No, so then you would prompt an LLM, take an input persona. So let's say the supermarket employee that works at the supermarket, and then you would prompt an LLM to come up with more personas that might interact with that specific persona. So it's not per se creating relationships between two personas within the same space, but then just using one persona as seed data for when prompting an LLM to come up with multiple personas. And that's a thing that the Persona Hub did. What a colleague of ours actually worked on, Agus, is creating this social network using personas as a example of how it might be used. Where he came up with a pipeline within Distilabel, how you might be able to generate like this knowledge graph of a lot of different personas. Based on these persona descriptions, actually created some attributes for those personas. So it can also not only be used for something like out of the box like predictive or generative models, but maybe also for like something like knowledge graph generation. And those are, I think, also interesting approaches potentially for synthetic data usage.
yeah, that's a knowledge graph of social network of synthetic personas. I saw like Kenneth Stanley and Jeff Clune, these like two of my favorite researchers. They do this research in like open-endedness, and they had created, I think, a social network of AIs. And yeah, it's such a crazy. I like this multi-agent society of agents is all really interesting idea. So I really want to come back. Yeah, maybe come back to synthetic data generator. You mentioned these pipelines. Like at Weaviate, we're launching the transformation agent. I think that it's not released as we're recording this, but it'll be released when we're publishing this. But so we're using like workflows to have like durable execution of these generated objects. So like if you're generating 100 objects and on the eighth object it crashes, it doesn't start back at one, it starts at eight. And so that's kind of like the systems perspective that we're seeing with this so far is when you're generating objects, you want to make it stateful. So if it crashes, you don't need to restart. So I'd love to just kind of know about like that. And then there's things like you maybe want to like parallelize and have batches of inferences, and just if we could just kind of get into like the systems of generating like the persona of generating a billion personas. Surely there's a lot of systems considerations you have to take into account. What kind of lessons are you learning as you're designing these systems that create synthetic data?
So I guess I can start that off, and then David will probably come in and take over. But so what we're seeing
Yeah.
with Distilabel is that its advantage is really its integration with other libraries like VLLM, Llama CPP, but to run locally, but also API providers like HuggingFace Hub, OpenAI, and everything else really. So uh, to run models locally, it uses a array. It deploys VLM via array, so it can distribute the model across GPUs using array. So that means that Distilabel itself doesn't really take responsibility for this, and it caches in a graph, in a DAG graph structure. So as steps fail, it just falls back to the previous step, and you can take off from where you left via a cache. It also integrates fully with the hub. So as you're generating rows, it's populating a data set on the hub, which you can go and explore as it's being generated. So you can use a data set viewer to look at that and to query it with SQL via the SQL console and these kinds of things. So you're able to watch the data set grow and it's all cached there for you.
Yeah, and I would say that on top of that, there's also the caching is actually done based on these configuration parameters that you pass when running a pipeline. For example, you might have like your configuration for one of the larger models with a slightly smaller batch size, with one of the smaller models with a higher batch size. There's also steps that you can include for example, for embedding text and then using those later on. So all of these things are actually, all of these configuration parameters are used when caching the outputs of the pipeline. So whenever you, maybe the pipeline breaks down because these things happen, it's like a high memory, high throughput system ideally. And then you would just be able to rerun the entire pipeline from where it left off. Because everything is loaded again in memory. So that's one of the things that's actually implemented within the underlying library within Distilabel, to actually deal with these kind of things. On top of that, as with a lot of other libraries, we rely, for example, on instructor for structured generation, on outlines for structured generation. Like all of these LLM frameworks are included. And on top of that, we try to capture the most recent verified research papers as prompt templates within Distilabel, which is also a way that we try to ensure more certain outputs from these synthetic data pipelines, because they've actually been verified in practice, instead of you having to come up with your prompt yourself. Ben actually tried to work a while back on integrating DSPy as well in Distilabel. Haven't I think it hasn't fully landed yet, but who knows? Maybe in the future, something like that for prompt optimization could be super useful as well. And that's all of these cool techniques and features to actually to ensure that you have like high quality. The pipelines are actually integrated within Distilabel, and then the synthetic data generator actually stacks on top of that. But then with a UI, with Gradio as a web app to make it way more approachable. So yeah, maybe we can dive a bit more into the flow there and the architecture if you want.
Oh yeah, that would be amazing. I guess if I could just react quickly to a couple of things, what you all have done with the Hugging Face hub is amazing. The SQL console, and yeah, having the synthetic data generator hooking up into the hub so the state is persisted onto the hub. That's so cool. I wish I had that in my grad student days. Of super cool. And yeah, because we kind of do a similar thing with like the database with Weaviate and using the hub as a database. And yeah, but DSPy, one of my favorite topics. I'd love to just zoom into this. Yeah. So if we could talk maybe more about, like you have a prompt to create synthetic data, and you could optimize that prompt. Yeah. How's all that going?
Yeah, so Distilabel takes a really like reproducibility kind of stance on prompts, which makes a lot of sense because you kind of want your library to work in a predictable and reproducible way. But if you look kind of beyond that, like there's a lot in DSPy and like prompt optimization to kind of squeeze the most out of these models and kind of get a consistency across different models. Because often what you're doing is like, let's say take 3 different APIs or 3 different models and generate a data set and use those different models and APIs for the sake of variety, but also scaling, just to allow yourself to get a big enough data set. So if you could optimize those prompts to create consistency across those models and APIs, that would be amazing, and DSPy would be perfect for that. So that was the reason why we explored that DSPy integration. But then what we found from using it, or I found from using it, was that actually you could just perform this prompt optimization offline with DSPy, like take those prompts and then just use them within your Distilabel pipeline. So actually like a formal integration was kind of so light that it wasn't really necessary. Like what I was doing was in like a sort of pre-start phase. I was creating my prompts and then defining them across the LLMs and then going into the Distilabel pipeline doing it. So in fact, what you might as well do is just work in DSPy, get your configuration, persist it, put it in source control, and then use that with your Distilabel pipeline, basically.
Yeah, I think our experience with DSPy is coming in a similar way, where with our agents that we optimize them, and then just kind of in the agent, rather than like we haven't quite come into the conclusion that we should build optimize as an API, but we're looking at like what contextual AI is doing. Particularly, it's one of my favorite companies is doing this like RAG optimization as a service, and I think. Obviously, I don't have to tell you guys at Hugging Face, you probably love this idea of let's train our own models and let's take that power into our own hands as the user and the customer of machine learning apps. But So I guess there's kind of two things about the DSPy synthetic data generation that I'd like to zoom in on, which is the signal that's used to optimize. And I see two signals. You could either use the signal of model performance, and there's a paper from Omar and collaborators that's called Path, which is about, they're generating synthetic queries to train an embedding model, or I think it's a re-ranker with, and the accuracy of the re-ranker, that's the signal that's used to go back to the data generator. But I think another signal you could use is just like, sort of like maybe come back to Jeff Clune and Kenneth Stanley, is this like open-endedness thing where it's just like the diversity of the generated data. Maybe that is the signal. And instead of just being a single prompt for the generation of an object, it's kind of like the LLM program, because you have like kind of, like the generate the objects as well as, maybe you have a prompt for how you're going to, I think I had misunderstood this. It's not really like PersonaHub is a mutation of David and Ben. It's more like just what might a friend of David be, something like that, right? But you have another prompt that's doing, there's more prompts than one prompt, so you have like this system. Sorry, I think I just clustered a ton of ideas in that one question, but I'd love to just ask about the signal that comes back to optimizing a synthetic data generator pipeline.
So there isn't a short answer to.
Oh.
Sorry, David. I think I'll start and then you take it up.
Go.
So there isn't really a short answer to this, in that DSPy is just kind of so broad and so much of a utility that you could optimize towards any signal really. But like, just to give you a couple of examples, one would be a signal for consistency across different models or APIs. So to say, okay, here's an instruction, here's a response. I want to make sure that all of the models give me a similar response from the same prompt. So I kind of optimize prompt templates across all of these models to make sure I get similar responses. Another example might be for complexity. So, and this comes from another paper, Data, not spelled as we'd expect, spelled DEITA, Data Efficient Instruction Tuning for Alignment. And in that paper, they basically evolve the complexity of the instruction that you're using to train. So they say, okay, explain to me how Weaviate works. Explain to me how Weaviate works in this situation. Explain to me how the database optimization within Weaviate works in this situation. And it keeps going like that, evolving for complexity and complexity. So in that way, you could take complexity as a signal and pass it back to DSPy and optimize your prompt to create the most complex or the most complex instructions. In that situation, obviously, you need an LLM as a judge or some other kind of classifier or regression model to give you this complexity signal. But it could also be something like quality, truthfulness, helpfulness. So you can incorporate these evaluation models that we already spoke about before, ultra feedback, and these kind of steps that are evaluating the instruction or response that we're generating.
Yeah, well, I guess kind of coming in on that, I'd love to touch on that point further. I know Anthropic had released constitutional classifiers. It's kind of about like, it's kind of like a guardrails classifier. And I think like oh man, I have so many ideas about this because you could either embed everything and you have that embedding based similarity, and that's how you say it's complex. But if you have a classifier, maybe we could just talk about the role of classifiers versus embeddings for either deduplication or complexity analysis. Is that too much of like a tangent that I've gone off with this?
Yeah,
But
I think that's also a thing that that HuggingFace, the research team at HuggingFace actually worked on the classification part specifically to assess quality of the generated data of the pre-training data, so to say. Where for small LM and small LM2, we actually wanted to have this high quality feedback data set. And then with the Argilla team, along with the community over at HuggingFace, what we did was create this multilingual version of the FarmWeb dataset. And in order to do that, we decided to train classifiers. And those classifiers were like being used as indicators for educational quality, where like 0 would be like normally commercials and these kind of things. And 1 would be like educational content from textbooks, and and like higher quality data. And that's also a way in which you would be able to classify, I guess, the quality of synthetically generated data in terms of complexity. Normally, it can be a bit like heavy in terms of computations compared to, for example, using maybe something more straightforward like entropy or diversity. And within the data paper, what they did was actually score initially all of the examples within the data set, then map them out within like the two-dimensional space, and then take the most representative examples, also filtered by score. So you would end up with the most representative examples that actually had the highest quality score attached to them. So that actually combines both of these approaches a little bit. And that's
Yeah.
normally, I think, more of a thing that you end up doing with like if you generate a high quality synthetic data set at huge scale. And for something like within the synthetic data generator, how we try to optimize for the signal was just like iteratively improving the pipeline. So we have these pipelines from Distilabel running in the background. Then what we did was come up with a prompt that actually composes a system prompt based on a dataset description. This system prompt then gets fed into the pipeline. Then we run the entire pipeline. You look at the data, you try to tweak it a little bit, but then we found out, for example, for the text classification data set, that the data wasn't diverse enough. So we decided to go and add on like these specific subsamples of the text classification labels for which the text classification data should be generated. Based on that sampling, we would then diversify because we kind of inject these specific labels into the pipeline at a certain stage. Then something like improving the model size could help as well. Eventually, like improving some of the prompts around creating the system prompt would help. And then you kind of iterate back and forth until you have like a meaningful, nice looking output from your initial pipeline. And we actually try to validate whether this was useful and meaningful as well by fine tuning a model on top of it, because that's also like one of these signals that you can actually get a meaningful model that actually works on top of your data.
Yeah, there are just so many interesting aspects to how this works that I'm having a hard time trying to parse all our conversation to extract questions. But I guess like with this, I just want to understand them. So I generate some email, like I'm trying to train a spam versus not spam classifier, just to say the most simple thing, other than
Yeah.
hot dog, not hot dog. But the we generate first we just generate 50 emails, and then now we're going to start introducing the label, like each of these 50 emails is generated just from the same prompt of like, you need to generate an email for the sake of span not san. Then we have these 50, and then we deduplicate them. Now we're trying to bring in the label, and maybe the prompt is now saying, hey, by the way, you've generated these 5 emails already, try to make it distinct from these ones. Like, do you integrate the data that has been generated into as a prior in the form of the prompt to
As of,
say, make it diverse?
as of now, we don't take in any user input, but it's something that we've considered doing, as in providing good examples for steps within the pipeline and then rerunning with those examples. It's a thing that you can actually do within Distilabel, but to capture that in a UI like the synthetic data generator, which is built on top of Gradio, this web app framework, is a bit like too difficult to integrate there. But it's a thing that yeah, were considering adding as well within like some tooling. And I think that these kind of approaches can really help whenever you are able to iterate quickly, when you are able to select good examples for these prompts, and then use them as few short examples, basically. That would be a great feature to have.
Yeah. Wow. So maybe if we could pivot a bit, I'd love to kind of talk maybe about what you think about doing this for like image data sets. Like something that I've done is, as I'm working on our Weaviate gorilla project, I asked ChatGPT to generate a green robot gorilla with like a W on its chest. And I'm so curious, like what interests me is I'm curious, like how many such gorillas can ChatGPT produce? Like like it seems like it has like an endless diversity of what it could create. And so that's kind of something that really inspires me with synthetic data, is like just seeing all the images it can create. And but I want to ask just about like if you guys have started thinking about extending this to images.
Yeah, so maybe I'll start off talking about image preferences data set that we built together, and then Davi can maybe give some more details as well. But so we worked on a project that was based on ImageSys's data set, which contained images and then like a prompt and then an image based on the prompt. So it would say like a beach scene, a sunny beach scene, and then there would be an image of a sunny beach scene. And so what we wanted to do was create a preference version of this data set so that we could use algorithms like DPO or ORPO that require this preference structure, which basically has like an input, two outputs. One output is chosen and one output is rejected. So like one is good, one is bad. And we wanted to create that format so we could use these algorithms. So what we did was we took that initial set of prompts and we evolved those prompts for complexity and quality again. So like to take our beach example, we take that example and then we'd say, okay, let's say like a Mediterranean beach on a warm sunny afternoon, a Iberian beach on a spring day. These kinds of evolutions to make it more and more complex and more detail. And then we would generate two images based on that text from two different models. So it was Flux Dev and Flux Schnell, which is a larger and a smaller model. And then we took that data set and actually a number of other models as well, Stable Diffusion, and we passed those to Argilla, the annotation UI, and we presented those two images to the community. And they basically browsed through those images and then selected the ones that they thought were the best. And this was a really fast-paced task because really all you're asked to do is like say which image you like, so it doesn't take much time. And the community moved really fast. I think the end of the data set was roughly 15,000 rows. And it contains, all of these various different images. And from working on that task myself, I can say there's like a load of variety in that because you're giving all of these extra bits of information that the model can then use. And since then, ImageSys went on to use that within their image generation arena, that data set, because it's a really high quality data set now.
Yeah,
Yes.
exactly. Yeah, and what we also decided to do at the beginning was actually source these different categories from like common categories that you normally see throughout image generation, like photographic quality or cyberpunk or anime. So it also made it way more the quality of the data set and use cases that you would be able to tackle with this data set, also way more interesting for the community because sometimes people want to, I don't know, fine tune specific anime related photos. Sometimes people want to fine tune for specific photorealistic photos. And it was also one of the side effects of doing it this way. We actually got some insights as to which model is performing better at which category for generation because all of the community actually voted for these different kinds of like for the different generated photos. So those were also interesting outputs. One thing though for this specific exercise was that the prompts that we sourced from the LMSys benchmark arena were human written prompts, unfiltered. So we actually found out halfway through the entire process that there was a lot of NSFW content, both in the prompt but also in the generated images, even when the prompt itself wasn't necessarily sexist or like not suited for work. So that's actually something that we ended up trying to mitigate by initially classifying the prompts with multiple classifiers to kind of get different angles based on using different fine-tuned models, and then also doing the same thing for the generated images to really make sure that there was no toxic content within the generated dataset before actually publishing it to the community. And the final check that we actually did was manually going over all of these photos ourselves to really ensure there was nothing like harmful in there.
Yeah, well, and I think I mean the whole responsible AI thing. I think Hugging Face has done an amazing job with that, and it's a huge thing I hadn't thought about. That you got to be careful about how the generated content could veer off, and so really cool to hear that consideration into that, and wow, awesome. So and so maybe coming back into the kind of technical thing, I think this again has a structure of PersonaHub where you've generated some object, and now you want to create a variation of that object. So in the case of images, you generate like a cat, and then you want to say, maybe black and white style, or like hand drawn style, or blah 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 style transformation. Whereas with the personas, these transformations are like relationships. So then I'm really curious just about the pipeline design. I think I originally tried to ask this question, but I asked it terribly. But like you generate K objects, and then for each of the K, you produce N variations to create K times N objects. Is that the right way of thinking about yeah?
Yeah, exactly.
Yes.
So we actually evolved for complexity and for style. So for this specific prompt that we sourced from the LM6 arena prompts, we initially came up with a prompt to evolve that prompt into a more complex version. So you can either choose to do that once, but as with genetic algorithms, you can actually also do that multiple times, then evaluate each evolution. Then based on these like scoring mechanisms that you might have for quality or complexity or any of the other metrics that we mentioned before, you can then decide which version of these evolutions is the best one. And then based on that output, you would then evolve for quality or evolve for style while ingesting something like black and white into the prompt. Okay, now we have this basic prompt and we want to evolve it once more, but then with a style component attached to it. And that's normally how you set up the pipeline. And what we decided to do for this specific approach was actually split up the generation pipeline for the prompts, because it's kind of fixed in terms of output, and also the eventual generation for the images.
Yeah, amazing. So the evolution, yeah. How do you think about? So you take in like you have to have some kind of like population selection algorithm, right? Yeah, maybe I just missed a detail, but yeah, like how do you like prune the population? Is it the deduplication, or is there anything else to?
So
No, so
the
it's evaluation within the specific, it's a pruning within the specific evolution of the same prompt. So for the prompts, you initially generate like the first generation, the first evolution, and then within these, for example, the data paper that Ben mentioned before, there's actually evaluation prompts included there to evaluate based on, for example, the quality or the complexity of the prompt. And in this case, we actually wrote a prompt ourselves based on those papers, based on the data paper prompts, to evaluate for style specifically, where if the score for the previous evolution would be higher than the next evolution, then we would still use the previous evolution. If the next evolution would be higher, we would continue with that prompt for the next generation. And then you would do the pruning in that way. And for the data paper specifically, I believe that they did this eventual pruning and based on the semantic similarity at the end of all of the evolutions. But I'm not entirely sure. But maybe Ben knows.
Yeah, that's correct. So they basically sorted by quality and complexity, as David said. And then once they had done all of that and they'd gotten this final batch, they embedded every single sample, sample in a data set, and then they selected the nearest neighbors, and then they filtered those down to take a diverse group based on nearest neighbors. So they wouldn't take too many samples from any one dense area, basically, to create this diverse data set using embeddings. So not quite deduplication, more of this diversity spread.
Yeah,
And
that's
I
so
would
cool. And
say,
that
so yeah, sorry, I was going to say,
sorry,
if you want to, I would definitely recommend going into that section of the data paper, the DITA paper, and reading how they do that, because it's kind of one of the only papers that did that in great detail. And the model that they trained out of it, Wizard LM, wasn't actually that performant, like the pipeline as a whole. But some of the individual steps that they've used are like really useful across the field and have been reused in different papers. And so it's actually like a really good read as a paper, but the takeaway benchmark scores from it don't really do it justice.
Yeah, and it also combines, I think, some of the earlier things that we've seen, like the evolution of prompts. They took that as a baseline, but then did it better and more diverse, where they evolved both the prompt as the completion to the prompt. So that's also interesting, as in some outputs from the data paper that you yeah are like fundamental for, I think, the synthetic data generation.
Yeah, wow, amazing. And that answers my earlier. I had this question about just like how the exploration is done with synthetic objects, and then kind of coming into that next step of like mutating them with these either relationships in the personas or maybe styles in the images, or like adding components to the image, like it's a gorilla and now it's wearing a hat, or yeah, all this. And yeah, I can't wait to read that the DITA paper you're referencing further. And yeah, it's just such an exciting topic. Also, so I kind of wanted to pivot into kind of maybe like a broader question about your experience with the synthetic data generator. And I mean, I think, you've really built this prompt to model kind of pipeline. I think it's something I've heard that phrase so many times, but I think really this is just an amazing case of it. It's got all these synthetic data creation algorithms. It's integrated with Hugging Face's hub for the data set, but also I imagine you connect it with the Hugging Face trainer and the Hugging Face model hub. And so just the full, prompt to model thing has been, you're solving it. And so I'm really curious, just like, if you're seeing like how you're seeing the adoption of that, like are people moving more into training their own models, like is this, yeah, I know that's maybe a big question to say, like, is this causing a lot more models, but I would imagine so, because all you need is a prompt and now you have a model and it can be smaller, faster. And yeah.
Yeah, so I think the nice thing that we have as part of this the synthetic data generator is actually the three components, where you have the UI, where you actually come up with a model. Then that UI, within the UI, you can actually customize and tweak your pipeline configuration. So both the system prompt, but also the generation arguments, and then you get normally a sample of the output data. There you kind of can see if the sample makes sense, if you like the output of the model, if the output is diverse enough, even though it's a small sample. And then you can actually scale up your generation. Currently, it's included for free, so we actually use HuggingFace inference endpoints. But then the size that you can actually generate is somewhat limited. But with 500 to 1,000 examples, you can already start generating a fairly decently sized data set. Then whenever you do this like larger scale generation, you wait for a couple of minutes, and then you can either go directly to the Hugging Face hub, where this data is actually formatted directly for fine tuning with one of these frameworks, either TRL or transformers or sentence transformers, because we include SFT, text classification, and retrieve augmented generation. But instead of directly pushing it to the hub and using it out of the box, what you can also do is actually go into Argilla to look at the data with like your own eyes by skimming through the data. We actually do some kind of biased feature engineering, like very opinionated feature engineering beforehand. We add some factors. We compare like some entropy. We look at the entropy. We look at the token length, and this really allows you to go into Argilla and even within Argilla do some additional filtering, verify labels, the certainty of labels. For text classification, for example, and then from Argilla export it to the Hugging Face hub. And that flow is now quite nicely integrated. And one of the things that we tried to do for showcasing like the prompt to model approach was actually for each one of these examples, we created an end-to-end workflow where for text classification, we fine-tuned modern words. For retrieve augmented generation, we also fine-tune for model birds based on generated data set. And then lastly, we for the SFT approach, we actually fine-tuned smaller LM, but then without touching any code, just by generating the data, prompting the data set together within the synthetic data generator. Then from that prompt, going to the AutoTrain implementation, importing the data there, pressing a button, and then a model rolls out. So that's quite nice to see.
Yeah, I love the connection then to AutoTrain as well. You synthetically generate the data, and then you've got the tuning algorithm of the model parameters, and it's just like also there's so much like orchestration of like the tuning of how you could do this. Especially like as obviously we spent the hour diving into how the mechanics of the data generation, how you maybe can put model performance as a signal that guides data generation, and just seeing that whole end to end is super cool. And And yeah, you also mentioned the Argilla data annotator, so you can, as a human, you could see some of these generated instances to maybe quality check it a bit. Yeah, it's all super
So,
cool. So
so
David, oh, sorry, man.
one thing that I think would be cool to add on there would be like the synthetic data generator within the prompt to model flow is like really like one tool within the ecosystem around data sets on the hub. So if you also look at the Data Studio, it's a new way of like exploring existing data sets with SQL, and it's integrated with a LLM, so you can just like generate queries if you don't know how to use SQL, and then you can create subsets of data sets which you could then use to create another data set, pass that back to the synthetic data generator, or train a model directly on top of that. And it's really becoming this like open source like suite on top of the hub around data sets.
Yeah. Yeah, one interesting thing that you also did for like the preference data sets before was, for example, querying the difference between two completion scores. So you have these evaluation scores, for example, for conciseness or helpfulness. You have two completions, and when looking at the difference for these scores, you might end up with like more complete difference examples, less differential examples. So when these scores are very similar, maybe you don't want to include them in your data set because they're difficult for a model to distinguish to. And all of these kind of cool computational features you can actually do with this, like this Data Studio text to SQL integration on top of every data set on the hub, with DuckDB like powering it in the background.
Yeah, hopefully Weaviate one day. Do you think about the like text to SQL, but like maybe like you want to use these like similarity search operators? If you maybe like like there's all this work like SUQL or Lotus is another, like extending SQL to have operators for semantic search, because I'd imagine that would be something I'd love to ask my synthetic
Yeah,
data set.
I actually played around with it this a while back, where because within HuggingFace, every data set actually gets a PR with Parquet files of this data, however you upload it. So if you upload JSON, we create a Parquet files on top of that. And those Parquet files you can actually load with DuckDB directly. And then based on that, you can do similarity search. But as of now, you're not able to create a remote index, and we don't have access to, like normally as a user for the hub, you don't have access to the database itself, so you can't create a local index either. So that's currently limiting. But for like doing vector search remotely using approximate nearest neighbor, so let's say for 50,000 to 100,000 examples on the Hugging Face hub, you can actually do that out of the box quite quickly. So that's something that we've been exploring a bit, but as of now, the limitation is with creating the index for approximate nearest neighbor.
Yeah, that's a really cool point of that Parquet to. There's like a lot of stuff about like open file formats and like Apache Iceberg and all that kind of stuff that maybe I don't know enough about to really go too deep into that. But yeah, that like custom file formats for vector indexes. Yeah, I'll save that for about another podcast. Yeah.
But one thing I would add on there is that there are two worlds in some ways. There is a machine learning and like a data world, and we're really seeing that on the hub. And so we built like the SQL console to allow machine learning engineers to look through their data set. And it was this immediate friction where like a load of machine learning engineers just don't use that much SQL anymore. And so like integrating it with an LLM to generate these SQL queries like kind of supercharged it, and people were able to like at high speed just look through their data set and get this big slice of data. So I do think, there's still two separate camps going on.
Yeah, I think this text SQL is going to be a huge unlock. And yeah, I love how it's integrated with the hub, as I mentioned earlier. This SQL console and all the data sets is just awesome. Yeah, super cool. So, David and Ben, I love to kind of end the podcast with this broad question about just what directions for the future AI excite you the most?
So maybe I'll go first. So for me, at the moment, I'm really like fixated and focused on education. So we kind of revved up our education a lot at Hugging Face. So we've got this NLP course. It's about 2 years old. And it's kind of like a classic course. I think most NLP engineers are familiar with it. And so, and if you look at the usage of it, it's kind of mad how many people have been through that course. And I really think as we start to educate more people and make more like open source material available, you'll just see like people from different skill sets and different areas coming into the AI space and doing more. Like for me, that's what's really exciting.
Yeah, and for me, I would say synthetic data still. It's also about opening up kind of the mode for more people to be able to join the LLM fine tuning world, to be able to just come up with an idea in your head and end up with a high quality data set. Currently, like tools like, for example, this Distilabel are a bit complex to stitch together in terms of pipelining, but there's like a lot of cool initiatives working with like more no code, low code approaches. I would say the synthetic data generator is super nice, but it's also in a way limited because we come up with this label pipeline completely in the background, and it takes some iteration for it to actually work. So in that sense, it's still limited. But I can imagine having something similar as the synthetic data generator with a more adaptive UI where people can maybe click together like a pipeline or a prompt system, or come up with like some of these cool data pipelines by having the UI kind of lead to best practices in synthetic data generation. That would be super cool for me, because then everyone can actually generate data, fine tune models without needing the explicit knowledge to do so.
Yeah, amazing. Well, yeah, obviously, super share that excitement as well as we've been diving into throughout the podcast. I think it's just such an exciting emerging area, this synthetic data generation, and Ben, to your point, yeah, I think just education is so powerful. I think Hugging Face has made so many contributions, and Argilla as well as yeah, I've been following it for a while. I feel like as long as I've been doing this, I've seen like Daniel and Argilla and so many contributions to the education of all this stuff. So yeah, and also congratulations on the course attendance. That's also just super exciting to hear. So, yeah, awesome, David and Ben. Thank you so much for joining the Weaviate Podcast. It's been such a fun deep dive. I'm so excited about the future of synthetic data creation and keeping up with the synthetic data generator. Thank you so much.
Thank you.
Thanks.